So we have seen that we have beryllium, we have all the compounds in group 2, and these compounds react in air, they form oxides. But what we should know, that the peroxides, it is only strontium and barium that react to form the peroxides. Then the nitrates, it is only apart from beryllium. Then the rest of the group 2 elements form the nitrates. So for the nitrates we have seen. So the nitrates, we have seen that for the nitrates it is only apart from beryllium. Then the rest of the group 2 elements, we have magnesium. So we have magnesium plus the nitrogen, we form the magnesium nitrate. These are solids, the nitrates are solids. So we form magnesium nitrate. So we have to balance the equation, nitrogen gas, which is okay. Then we have formed the nitrates have been formed. So this is the reaction there. They asked us for the conditions. The metal must be heated. The metal must be heated. Then even dry. If you are talking of oxygen, then the oxygen must be dry oxygen gas, then dry nitrogen gas, just like that. So go to part B of the question. Reaction with water. The reaction with water, we see that the group 2 elements have magnesium, beryllium. Beryllium does not react with water under any condition, because beryllium does not react with water under any condition. Because the hydroxide of beryllium, it is highly insoluble. So that hydroxide, of course, the reaction will immediately stop. The solubility of the hydroxides, increases down the group, whereas the sulfates of this group 2 elements, the solubility of the sulfates decreases down the group. First stop. Yes. So plus hydrogen gas. So all these elements, we see that they react with water. The rest of the elements will react with cold water from the hydroxides and then hydrogen gas. So we see that here the hydrogens are 4, 2 plus the other side. So the rest, you either go on writing or you can generalize and say, if I have one metal here, which is a solid, reacting with the water, which is a liquid, giving us this side magnesium, the metal hydroxide, and then plus hydrogen gas. Then you come here and you say, where? Try to make sure that we are seeing all these things. Where my hand is, it is where we must be. Where M equals 2, we must have magnesium, calcium, strontium, barium. Yes? Then now, the next part is with the reaction with the dilute sulfuric acid. The reaction with the dilute sulfuric acid. Now, the reaction with the dilute sulfuric acid. Here I can generalize it with the reaction with all the dilute acids. You see that these group 2 elements, when reacting with dilute acids, beryllium reacts in a unique way. Beryllium reacts with warm dilute acids or heated acids. Warm beryllium, warm dilute acids. Then the rest of the elements, react with cold. Remember, these are the conditions they asked from us: cold dilute acids. But the question was specifically dilute sulfuric acid. Dilute sulfuric acid. So now, remember I talked of some part where I say that the solubility of the sulfates decreases down the group 2 elements, meaning that we shall have our beryllium and then the magnesium. These ones can react with the dilute acid, forming the sulfates and then hydrogen gas. Then the rest of the elements, for them they react to form insoluble sulfates, which later stop the reaction, and therefore the reaction does not continue. So the insoluble sulfates are formed by the calciums, the strontium, the barium, like that. These two, they are the only ones where we can write the equation and say that beryllium, which is a solid, react with the dilute sulfuric acid, giving us the beryllium sulfate, which is a solid, plus hydrogen gas. And then the magnesium, which is a solid, react with the sulfuric acid, giving us magnesium sulfate. Magnesium sulfate plus hydrogen gas. Now this time round the question was asked us for the dilute sulfuric acid, but you may come across whereby they are asking for the concentrated sulfuric acid. Concentrated sulfuric acid is an oxidizing agent whereby this can oxidize these two compounds, giving us beryllium sulfate, sulfur dioxide, and then hydrogen, and then water. They oxidize these elements, and then for it, this concentrated sulfuric acid is reduced to sulfur dioxide and water. Then, being reduced, so that's what I can talk of. Let us continue to complete this question. Next part is asking us to look at the atomic radius and then the melting points. The melting points. When we look at the melting points, it is the same part that we are looking at with the boiling points. We take them together, we move them together. So, we start with the atomic radius. In any group, the factors affecting the atomic radius, we have the nuclear charge. And then, if we call our nuclear charge baby Z, yes, then we have, this is the nuclear charge. We have the screening effect or the shielding effect in some books, but then this is the screening effect. We can call it the S, yes? Speak English. And this is the screening effect. Are you seeing him? This is the, are you seeing the what? This is the screening effect. So, this is the nuclear charge. So, we have what we call the effective nuclear charge, which is equal to Z minus S. So, if the screening effect is small, it means that the effective nuclear charge will be big. When you look at errors in math, it means that here we are subtracting off a small value. Yes, here where I point is where you. Is it okay? Is it okay, friends? So, members, you should like the videos. Like the videos. And then comment. Yes, I need to receive your comments. Then the questions you submit them through WhatsApp or those very comments. Okay. So the atomic radius. We see that when we are going down the group, the number of energy levels is increasing. The number of energy levels is increasing from beryllium go to magnesium. Where I write is where you must be seeing where I'm writing. So beryllium, magnesium, calcium, strontium, barium. As we go down this group, we see that the energy levels are increasing, but the elements, the number of elements in the outermost level, energy level, it remains constant. There are two. So someone might even ask you for the general electron configuration of the group 2 elements. It is just NS2. It has two. All the elements have 2 electrons in the outermost energy level. So, since the number of energy levels is increasing, then the screening effect increases. But also, we see that as we go down the group, the number of atoms, the number of protons is also increasing. But then, since a full energy level, fully filled with electrons, a full energy level is added innermost of those 2 outermost electrons. So we see that the screening effect for it increases than the increase in nuclear charge. So how do we explain this? How to explain it? We say down the group, nuclear charge increases as protons are added to the nucleus from element to element. Then screening effect increases as a fully filled energy level of electrons. You have to put these electrons, fully filled energy level of electrons is added from one element to another. Then we continue and say increase in screening effect outweighs the increase in nuclear charge. Therefore, effective nuclear charge, since the screening effect is big, then the effective nuclear charge so outweighs increase in nuclear charge. Therefore, so effective nuclear charge decreases from element to element down the group. Since the effective nuclear charge is decreasing, then if the effective nuclear charge is decreasing, then the outermost electrons, they will be less attracted by the nucleus, or they will be less strongly attracted by the nucleus. Therefore, the atomic radius increases. Then we go to the boiling points. Boiling points or the melting points. This explanation is the same for the boiling points and then the melting points. But then, members, we should take keen to look at. The values provided in the table. These things can change. So down the group. When you look at the group two elements, down the group, the melting point decreases. The melting point decreases. How? Stop. So the melting point decreases. We see that we have our. If the melting point is decreasing, we have our beryllium, magnesium, calcium, strontium, barium. The melting point decreases. Maybe this is the highest value. Okay, the melting point decreases. This is the highest value. So we decrease like this. We reach, this is maybe beryllium, this is our magnesium. But then we observe that calcium has a higher melting point than magnesium. Then the rest, the graph will just slow. Calcium, strontium, barium. So the melting point generally decreases down the group, simply because down the group we have seen that the atomic radius decreases. Since the atomic radius increases, down the group the atomic radius increases. As we saw that the outermost electrons are weakly attracted and therefore strongly repelled from the nucleus, and therefore increasing the atomic radius. So, since the atomic radius is increasing, we see that the bond length increases. As the bond length increases, the bond strength decreases. The bond strength decreases, therefore we need less energy to break and then for the elements to melt. Then, the difference here that we have to explain, magnesium and then calcium. The magnesium has a lower melting point than, an abnormally low melting point than calcium, because magnesium has a different structure from that of calcium. These structures, we shall look at them in the higher levels as we advance with the education. But for now, what you should know that magnesium has the hexagonal closed party structure. Then calcium has cubic closed party structure. The difference in their structures causes magnesium to have a lower melting point from that of calcium. Stop.
Sasa kwa kuwa mimi naweza sana.
Don't speak. Stop. Part of the question is, the last part of the question is asking us simply that all the elements belong to group 2, but then why does beryllium? Why does beryllium show similar properties to aluminium? This is the diagonal relationship, the similarity in the chemical properties of the diagonal elements with their diagonal neighbors of period 3 diagonal relationship. So it is due to the beryllium has the smallest atomic radius. Beryllium has the smallest atomic radius. It has the highest charge density. So since the question is involving comparison, so we need to say that the atomic radius of beryllium is almost equal to that of aluminium. Then we talk of the charge density of beryllium is almost equal to the charge density of aluminium. The electronegativity of beryllium is almost equal to that of aluminium. So
tu ama.
organize this. Start.
Go.
Radius, charge density, electropositivity. Start. So
Kamba kwa Mungu. Mami Edi. Edi ngako yenu.
Yes. Charity.
Jise idoge mankugobon. Akakasema ko weidawo ale kutoto yanga. Akasema weidawo chirikiza.
Gina akasana kanomia echi muno. Akasana kanomia echi muno.